Have you ever seen code like this? It's called a list comprehension, and it can replace an entire loop with just one line of code. I know the syntax can be a bit intimidating, but don't worry, we have clear visuals to break down each part. To familiarize ourselves with the syntax, let's start with a simple example. Suppose we have a list of numbers and would like to square each one. A natural way to attack this problem might be to use a for loop. First, we create a new empty list that'll store the squared numbers that we'll calculate inside the loop. Then, we write a for loop that iterates over all the numbers in the original list. Within the loop, we square the current number and append the result to the new list. Finally, we print the nums squared list. This approach works, but it's a lot of code to accomplish something very simple. Luckily, Python provides list comprehensions, which allows us to do all this on one line. We can write a list comprehension by following a few easy steps. First, we write a pair of square brackets like we would to create a regular list. Then, instead of manually typing out each item in the list, we'll write a three-part expression. This expression will act as a blueprint for generating each item. The easiest way to write the expression is to start with part 3 and build backwards. Part 3 specifies the existing list that we'll use to create our new list. In our example, this is the nums list. Next, part 2 starts with the keyword for, specifies a variable name to represent an item in the existing list, and ends with the keyword in. In our example, we'll use n as the variable name. Notice how together parts 2 and 3 mirror the structures of a for loop's header, just without the colon at the end. Lastly, part 1 describes the operation or transformation that turns each item from the original list into an item in our new list. In our example, we want to take each number in the numbers list and square it. Congrats! You've created your first list comprehension. Let's assign our new list to the variable nums squared and print it. Running the cell, we get the same results as before, but with a single line of code instead of 4. Using a list comprehension saves a few lines of code since there's no need to initialize an empty list or explicitly append elements. Awesome! While list comprehensions are great for lists of numeric data, they can also be used with lists of other data types. For example, suppose we have this list of TV show titles with inconsistent formatting. To fix these inconsistencies, we'd like to capitalize the first letter of each word only using the title string method. Like before, we could do this with a for loop. First creating a new empty list for the correctly capitalized TV shows, then iterating through each show in the TV shows list, applying the title method to get the properly capitalized title, appending the formatted title to the new list, and finally printing the new list. Again, this works fine, but why write 4 lines of code when you can do the same thing with a list comprehension in just one line? Let's simplify this code. First, we write a pair of square brackets to create the list. Then, we can copy and paste the header of the loop, minus the colon. Next, we apply the title operation to format each TV show's name. Finally, we assign the results of the list comprehension to the TV show's cap variable, and print the result. Running the cell, we get the same output as before. Great! In the examples so far, we've created new lists by applying operations to all the items in an existing list. But sometimes, we might only be interested in some of the items in the existing list. For example, suppose that we're only interested in the TV shows with 10 or more characters in their title. We could create this sublist by adding a conditional statement inside our for loop. The statement would test whether a title has 10 or more characters. If the condition is satisfied, we transform the title and append it to the new list. Running the cell, we get a well-formatted list of titles with 10 or more characters. To get the same result using list comprehension, we can simply add the same conditional statement at the end of the comprehension. Running the cell, we get the same output, but with a single line of code. Awesome! Now you know how to use list comprehensions to transform existing lists, but we can also use them to generate entirely new lists from scratch. For example, we can use a list comprehension to quickly square the numbers from 1 to 10 without manually creating a list with the numbers themselves. To create this list comprehension, we first write square brackets like before. But now, instead of specifying an existing list, we use the range function to generate one. In the range function, we pass 1 as the lower bound and 11 as the upper bound. The upper bound is exclusive, so this range function will only produce numbers from 1 to 10. Next, we write the familiar for n in. And finally, we tell Python to square each number. Running the cell, we get 1 through 10 squared. Great! So far we've seen how list comprehensions cut down on the lines of code. But that's not their only benefit. List comprehensions also have performance benefits when it's compared to for loops. To see this performance benefit, let's build on our number squaring example. Instead of squaring the numbers from 1 to 10, we'll square the numbers from 1 to 100 million and see how long it takes. To track the runtime, let's import the time function from the time module. We'll record the start time by calling the time function just before the list comprehension runs. And we'll record the end time by calling the time function just after the list comprehension ends. Finally, we'll write a print statement where we calculate the difference between the end and start time to see the runtime in seconds. Fast forwarding the execution, this list comprehension takes about 10 seconds to run. On the other hand, if we write a for loop to square the same numbers, recording the start and end times, it takes about 17 seconds to run. List comprehensions typically run much faster than the equivalent for loops because they skip the overhead of method calls like append and execute the entire operation in a single optimized step. To take advantage of these performance gains and write more concise code, it's a good idea to use list comprehension when logic is simple and transforms or filters items in a sequence. But while list comprehensions are often faster, they're not always the best choice. While it is often possible to write complex loops as list comprehensions, doing so can make your code harder to read and understand, which raises the risk of introducing bugs. For example, suppose we're working with this list of numbers and want to square only the even numbers and keep the result only if it's greater than 10. To do this, we can write a loop that iterates over the numbers list. If the number is even, then we square it. Then, if the resulting square is greater than 10, we add it to our results list. Technically, we can turn the loop into this list comprehension. However, I find this list comprehension really hard to read. And since the list of numbers we're iterating through is small, I find the readability benefit of the for loop outweighs the performance benefit of the list comprehension. However, with the nums list ranging from 1 to 100 million, performance becomes the bigger concern. To truly speed things up, you might benefit more from parallelizing your loop than from using a list comprehension. By parallelizing your code, you can execute multiple iterations of your loop at the same time, drastically improving efficiency. If you're curious to see how this works, we've left a link to our video on parallel processing in the description. Awesome! Now you understand how list comprehensions work and when to use them. We're working on lots more Python explainer videos just like this one, so be sure to subscribe so that you don't miss out. If you have any questions or topics you'd like to learn about, let us know in the comments below. We'd love to hear from you. Thanks for watching!